So this question is asked by another colleague, and the question is, can X2 handover takes place without evolved packet core involvement? Because on some of the sources it has been written that X2 handover can take place without core network involvement. So there are certain scenarios where handover will take place without core network involvement, but let's take a look what happens for X2 handover. So in order to answer this question, let's take a look here and then draw the scenario. So any handover has mainly two phases, although it is divided as three phases when you look into the detail: preparation phase, execution phase, and then completion phase. That's how usually it's divided. And when we are talking about X2 handover, there is an interface which is termed as X2 interface between two eNode Bs, and then the two eNode Bs needs to have communication with the core network. So let's draw it over here. Let's say this is MME, and then the other one, let's say this is SGW. Okay, so in this case, this is MME communicating with both the eNode Bs, and then we have SGW communicating with the two eNode Bs. Let's call this A and B. Now, if in order for any handover to be considered as X2 handover, the preparation phase of the handover needs to take place through X2 interface. So in this case, the X2 interface, meaning when I say preparation phase, meaning before actually the handover execution or the UE starts moving from one eNode B to another eNode B, the communication or asking from one eNode B to another eNode B is from the source should ask the destination that the UE wants to do handover, do you allow it? And if that communication is taking place through X2 interface, then it will be considered as X2 handover. So that what defines if a handover is X2 or S1. If preparation phase is taking place through X2, it is considered as X2 handover. If the preparation phase is taking place through S1 handover, it will be considered as S1 handover. So the question is, can X2 handover take place without core network involvement? So let's say majority of the signaling on X2 handover take place over X2 interface. The preparation phase takes place over X2 interface. The data transfer takes place through X2 interface. However, as a result, the final portion where the connection of SGW changes from source eNode B8 towards the target eNode B, that does require S1 path switching from old eNode B8 towards the new eNode B, in this case, which will be, and that will require S1 path switching, which is a core network signaling. So in this case, S1 path switching, the S1 path switching, that is core network signaling procedure. Okay, so that will be involved even in case of X2 handover. So the simple answer is, it is, even though if X2 handover is taking place, conventionally it will require the least amount of core network signaling, which is switching path from old source eNode B and forwarding data towards the new target eNode B. Assuming if MME is the same for the two eNode Bs and SGW is the same for the two eNode Bs. So in that case, yes, it will involve core network signaling as well. Even though not too much, but yes, it will involve. The only case where you will not have any kind of involvement from the core network is the scenario where your handover or the UE's handover is taking place within the same site. What do I mean by this? Let's take a look here. So in this case, what I will say, let's say this is alpha, beta, gamma. So if handover is happening within the eNode B, also called as intra RBS handover, in that case you will not have core network involvement. The decision of handover and confirmation of handover will happen within the RBS scheduler itself. So if the UE is moving from alpha towards beta, so that decision and confirmation will be done by the eNode B scheduler itself. And that handover is not even termed X2 handover, it will be termed as intra RBS handover. Intra RBS handover. So that is the scenario where you will not have core network signaling being involved. Otherwise, even in case of X2, least amount of signaling is involved, even if you have same SGW serving the two source and target eNode B. The least amount of core network signaling, which I mentioned, is used during S1 path switching. So that was the answer to that question. Thank you.